Hi, everyone. I'm going to give everyone a little moment to log in, and then we'll start. All right. Well, good afternoon or good morning, wherever you're at today. Welcome to our webinar co-hosted by the New York Oracle User Group and Oracle partner Viscosity North America. We have a full house today, a full virtual house that is, for today's presentation by one of our most favorited speakers in the Oracle realm from Quest Software. We've got Janis Griffin today. Super excited about that. Reminder, this presentation is live. So please take advantage of Q&A. You've got expertise in the house. Take advantage, add your questions to the Q&A field, not the chat box. If you have any questions about the platform, about Zoom, if you're having any issues, or if you have generic questions, you can put those in the chat and I'll get to those as I can. If you've got questions for Janis, again, they belong in Q&A. She'll get to them following today's webinar. So once again, this is co-hosted with NYOUG. My name is Monica Lee. I'm the marketing director for Viscosity North America. You'll learn a little bit about us real quick after this. But first, I'm going to hand it over to Coleman. He's going to tell you about NYOUG if you're not familiar with them already.
Thank you, Monica. So welcome to this shared webinar series between Viscosity and between New York Oracle Users Group, which we formed almost 40 years ago for the exchange of ideas, assistance, and support among users of Oracle software products. You can connect with us on Twitter, Meetup, and if you have abstracts, please go to our website and click on Submit Abstract, and we'll gladly put you down as a future speaker for this series of webinars. We're on LinkedIn, Facebook, and of course our website is nyoug.org. And again, I want to thank Viscosity North America for co-hosting this series of webinars. And in a moment, we'll talk about Janis.
Thanks, Coleman. All right, my awesome colleague Katie is going to give you, I promise, a super quick rundown of Viscosity. Hopefully you are familiar with us already, but if you need anything, Katie's your girl. Email her after this webinar if you need anything. And yes, today's session is recorded. You'll get this session and the slide deck following, and Katie will talk more about that.
Awesome. Thanks, Monica. Good afternoon, everyone. Thanks again for joining us today. My name is Katie Barnes, account manager at Viscosity. And as Monica said before we get started with the presentation today, just wanted to give you guys some information about who we are and what we do. So we are an Oracle partner. We work very closely with Oracle Product Management, and we now have 6 Oracle ACEs on our team. Many Oracle customers are increasingly relying on professional service partners like ourselves to serve as trusted advisors and to help make better purchasing decisions. Our business model at Viscosity is very simple. We work hard to build trusted relationships, and we implement technologies and solutions when the time is right. We're always happy to be a resource to you, whether that be tomorrow, next year, or even later down the road. Our areas of expertise fall under 3 pillars: data, apps, and infrastructure. A large bulk of our business is on the database side, including data integration, data warehousing, zero downtime migration to latest versions, including 19C. Overall, we help improve performance at the database level. In our applications practice, we do a lot of Apex development, EPM, ERP, we develop custom apps. And lastly, our infrastructure and hardware practice includes Oracle's public cloud offering, bare metal, engineered systems. We were actually named Oracle's ODA Partner of the Year back in 2019. So as you can see here, we're very active within the Oracle community. We do pretty much everything when it comes to Oracle, but these are some of our more broadened areas of expertise. So the lovely people that you see here on this slide represent some of our leaders at Viscosity and our Oracle ACEs. We actually have 6 Oracle ACEs now. These guys are amazing. They are frequently presenting webinars and at user group conferences, and they're all extremely eager to meet with individuals like yourself. Here are some of our other services, and I'll just briefly highlight a few of them. We have experts on Oracle license management that have actually come from Oracle and worked in that space for several years. We provide all of our customers with knowledge and best practices on how to manage and maximize your Oracle investment. We're probably most known for our zero downtime migrations and upgrade services. We've helped customers migrate from AIX to Linux with zero downtime, and more recently have been helping our customers with upgrading to Oracle 19c. Our performance health checks allows us to fix pain points before they become real issues for our customers. And lastly, we also offer a full stack of DBA services as well. This slide showcases the work that Viscosity has put into becoming trusted advisors who have actually written the books on Oracle's latest technologies and versions, anything from virtualization, pluggable databases to Oracle Exadata. We offer consulting and strategy meetings to assess any of your current projects, pain points, or team goals, and to share our resources with you, like the books that you see here on this slide. So if you're available to connect with one of us, shoot me an email and we'll schedule a time to connect. Alrighty, and last slide before I hand it back over to Coleman to introduce today's speaker. If you haven't already checked out our events page, please do so using the URL that you see on this slide. We update this page on a monthly basis with our webinars, workshops, and other great events that we have going on, and it's a really great resource. I will be sending out an email to everyone probably sometime tomorrow with instructions on how to register for your free Orapub membership. This is where you can access a copy of the slide deck and the recording of this presentation as well. So with all of that being said, thank you for listening, and I'll go ahead and pass it back over to Coleman.
Thank you, Katie. So, Janis Griffin has over 30 years of Oracle DBA experience, including design, development, and implementation of many critical database applications. Before coming to Quest, Janis held DBA positions primarily in the telecom network industries, working with both real-time network routing databases and OLTP business-to-business applications. As an Oracle ace, Janis has mentored other DBAs and developers on best practices in database performance tuning. So once again, we want to thank Janis for contributing as a webinar today, and also thanking the Viscosity for co-hosting the series of webinars with us. Thank you again, and enjoy the webinar.
Thank you, Coleman, and also thank you, Viscosity and the New York Oracle User Group. I'm happy to be here. I want to welcome everybody to my presentation on Oracle 19 automatic indexing, and hopefully you'll get something out of it. So let's get started. Coleman did a nice job of introducing myself. I just want to add that I have been a long-time DBA. I actually started out with Oracle version 3, so been around for a long time. I've been at Quest now for 4 years, and I enjoy working with our customers and prospective customers, looking at their databases, and always comes up with, well, how do I tune it? Or, I've got this one SQL query, and how do I make it run faster? And so looking at new, releases and as they come out and what Oracle's done, it's always kind of fun to see what you can do to improve with the features. So that's why automatic indexing to me is so interesting. So we'll get started with, we'll talk about automatic indexing, what it is. We'll also talk a little bit about what's new in 21C. I mean, actually 21C came out kind of not really announced. It's not a long time supported version of Oracle, and I wouldn't see a whole lot of people going to it unless they have some new feature that they really have to have, because it's not supported in long term. Actually, 19C is a long one. So, but there are some new stuff for automatic indexing in it. So I'll talk briefly on that. We'll also get into the high level steps of how it works. And then we'll talk about DBMS auto index package, how to make it work, how to control it. And then we'll get into several case studies, how it works, how to drop automatic indexes. Does the DBA have any control? Because, it's always scary when Oracle takes away some control from the DBA, or at least that's my take on it. So automatic indexing, what is it? Well, basically what Oracle did, it took, years and years of expert, tuning knowledge and actually put it in the product. And so, it basically, in the background, runs a task that tries to identify indexes based on table column usage, and tries to create them and test them and see if it'll actually improve performance. If it does, it'll actually help that. It requires no DBA involvement. which is, again, kind of scary. So that's why I wanted to, get underneath the covers and see what happened, what happens with it. The one thing that's good about it is DBAs can set preferences. They can view reports to see what the impact is on, what automatic indexing is doing, what indexes they created, and actually get really deep dive into the rationale about why they chose that index. So it's interesting. It's a good learning tool, even if you don't have Exadata, because basically automatic indexes is only available on Exadata. But there's some things you can do to use it around, not fully supported, but we'll talk about that coming up in the following slides. How it works is it works incrementally. It needs to, because if you think about workloads in a database, they're continuously changing. More data is either added or deleted. More people are accessing it, or maybe there's less people. Maybe there's other applications competing. So it has to work incrementally, iterative and continuous. Basically, how it works is it creates invisible indexes, and what it does is it creates them with a prefix of sys_AI, so you can always identify automatic indexes. And then basically it tests them behind the scenes, and if performance is improved, it just basically turns them to visible, and so the application can start using them. If there's no improvement, it keeps them marked, the indexes unusable and invisible. And then later they're removed, and I'll show you how that works as we go through this. These are the high-level steps. Like I said, there's no DBA interaction at all, where you can audit the process by looking at the reporting features that they give you. And so basically, we're going to talk about each one of these steps: the capture, identify, verify, decide, the validation, and then the continuous monitoring. So what automatic indexing out of the box is not turned on. So you have to actually turn it on. But when you turn it on, basically what it does, it starts capturing application SQL history into a SQL repository. And what it is capturing is actually the SQL statement itself, any execution plans that it is using, as well as bind values, execution statistics, all this information around that SQL statement. Of course, the workload, it's capturing all of that to get an idea of how it's performing. And then it identifies these indexes that may help, with the newly captured SQL statements. And so what it initially does is once it identifies it, it creates indexes that are unusable, invisible indexes. So metadata only, no space, not taking up any space, but it says, okay, I think these may help. And then also, it evaluates existing indexes. So if you have indexes already, like maybe it's an old application where you've indexed and it's actually looking at those indexes, it will actually obsolete those indexes, with the newly created indexes. So it kind of does a logical merge. And then it goes into the verify phase, where basically it asks the optimizer, if the index will even be used by the captured SQL statements. And how it does that, it actually materializes the indexes. It runs, the SQL to validate that the performance is improved. And then it also does this outside of the application workflow. So your workflow can be running, the application can be running and won't use these indexes until it decides that they're good for, the entire process. And how it does that is it decides, and it does that by looking at the performance. And if all statements are performing better, then it'll mark the indexes invisible and it'll introduce them into the workload. However, if performance is worse for all statements, they just remain invisible. And like I said, they'll later be removed by a process that sits out there and just kind of looks at how long they haven't been used. And then if the performance is worse by some statements versus others, it basically has this way of marking indexes visible for the statements that are running good, and not letting the SQL statements that have regressed see those indexes. And I believe it does this with hints, and you'll see that later on in a few slides, because it actually has a auto index hint whether to use it or don't use it. So I believe that's how it's actually controlling that. And then online validation, basically it looks at the new indexes, it introduces it with the full workload, because so far we've just been looking at new SQL statements and tuning those. But now it looks at the other statements that are online and see if there's anything that's going to be regressed by introducing these new indexes. And once, it only does this in one session outside of the whole application workflow, and it's only allowed to use those indexes in that one session. So again, you don't have to be worried about your application doing this process because it's doing it behind the scenes. And then finally, it monitors it continuously. It does this, with in the background, and then it actually, unfortunately, my slides are hidden here. I don't know if I can get, okay, there we go. It actually creates the index. And if there's any indexes that aren't being used, like I said, it will actually drop them later on. There's a question that says, will it drop user created indexes? No, it will not, unless it actually you have a user index that may be interfering with an index it comes up with. It may look at that and say, okay, I'm going to do this logical merge and make sure I'm not losing an index, but I may be adding columns to it or reorganizing that index to make it run more efficiently. Okay, this is kind of a Oracle's slide, I guess. You're telling why you would use automatic indexing. And what they're saying, it's great for both OLAP and OLTP processing. However, especially if you have mixed workloads. In fact, there was papers done on, hey, you don't have to have a data warehouse anymore because we could do automatic indexing and you can actually, kind of control, the analysis of the data and have your OLTP environment still work and perform. But it's great for mixed workloads, but it's really critical for online transactions because it's good to keep those queries running really fast and efficient. You can apply automatic indexing, can be applied to tuned and untuned applications, and how that works. If the application is already tuned, it's going to look at existing secondary indexes, and they may be outdated. And so it'll might drop those, and it might then substitute those with automatic indexing. And then it's also important that, especially if you've got an application that's been around for a long time, yeah, it was tuned originally, but we haven't looked at it in a while. And of course, the data has grown, or something, workloads have changed. It might be missing indexes. So it's good for older applications that have been sitting out there for a while. And then untuned indexes or untuned applications, it'll actually look for existing indexes that support primary and unique keys, and it'll try to come up with some of those, but then it'll actually add secondary indexes according to workloads as needed. What's neat about automatic indexing, in my opinion, because I don't have Exadata, is that you can turn it on and you can use it in all stages of an application lifestyle. So if you think about it, when you're developing a new application, a lot of times developers are marching to a date. Just get it working, get it in production. We can't fall behind schedule, all that. They don't have time to look at performance. So they may add indexes, but maybe they're not the right indexes, or maybe they're, maybe they don't even have time to look at performance. And, that's the worst case scenario. But through my lifetime as a DBA, I've seen, sadly, applications get put in production only for it to fail because they don't perform. There's all kinds of surprises, that it didn't work. And, a lot of this is due to not looking at performance ahead of time. So this is something that's free, that you could turn on and have it, create indexes during the whole life cycle process, during development, Q&A, if you're staging and doing a production load in a test environment. What a better way to have, someone tell you, these are the indexes we think you should have. And then you can evaluate whether you want to put them on or not in production. So it's kind of a neat feature that way. I had the opportunity when this feature came out, at that time I was an Oracle ACE director. So we had, at Oracle Open World, we would all meet and have a day of, what new features were coming. And so we looked at automatic indexing. And I was really surprised, what they came in. Not only do they give single and concatenated indexes, but they also will create function-based indexes, and they also have compression in their indexes. So you can turn all that on and have control with whether you want compression or not. And in 21C, what's new is now they've added partition tables. I don't believe that was there in 19C. So if you have huge tables of partition, they index those as well. So it's a pretty smart feature. How it works is basically it runs in a task. And so it defaults to the same database that an application is running in. So basically, in indexing, what it does when it runs this task, it looks at the CPU, memory, and storage, and it controls it through Resource Manager. So it limits it to one CPU. So it doesn't overtake the system. And they've actually done a little more work with this in 21C about, with the cursors and, kind of a heavy load on that. They've actually fixed that in 21C. But, what the DBA can control with this is actually the temp space where the indexes get billed, and as well as the table space that the auto indexing sits in, as well as if you leave it in default, you can actually control how much space the auto indexing takes up. There's a question here from Robbie that says, does it create both types, bitmaps and B-tree indexes? And I believe the answer there is no, it doesn't create bitmap indexes yet. It's all B-tree indexes, at this time, and even in version 21C, still that. It is, and another question from Elizabeth says, is it available in Exadata only? And yes, that's true. It is, good segue to my next slide. It is, available in Exadata only, or, engineered systems. You can do Exadata, as a, cloud service that has it as well. But basically, you can't use it in, any of the others environments. However, there is a workaround, and it's not supported, so it's not supported to use in production. So you don't want to use it on a real system, or, maybe you can use it in your, application, development life cycle, but you can set a hidden parameter. And so in the CBD assist DBA, all you do is alter session, set _exadata _feature _on equal true. And of course, I put it in my SP file, especially if it's a dev or test environment. And then I just rebooted the machine so it takes control. Like I said, it's not supported. So if you turn this on and have issues, I would never do it in production, but you can get a wealth of information by turning on in your other environments and maybe seeing, what it suggests, and then, manually doing it in your, production environments if you don't have Exadata. Okay, so hopefully that helped answered. Another question just came in about partition tables, if they're global or local indexes created. And unfortunately, and that's another good segue, because I really hoped before I gave this presentation, I just got through standing up a 21C environment and started applying all of my tests for automatic indexes. I have not answered that question yet, and as far as I know, I don't know which it does support. So I don't want to mislead you in doing that. I'm sure they probably have it in the documentation somewhere, but I've just started looking at 21C, and I really wanted to get into this presentation. So stay tuned. I probably will have a different presentation shortly. I'll say, okay, so again, with every new feature of Oracle, there's always a package. There's always that one package that controls it. And so the package that controls automatic indexes is called DBMS Auto Index. And basically, we're going to walk through all of the things you can do with DB Auto Index. And the biggest thing is you can configure it. It's turned off by default. So, and especially if you don't have Exadata, you want to set the hidden feature, and then you can actually either you configure it to implement, and that basically turns on auto indexing. So when it creates the new indexes, it'll actually be visible to the optimizer, and it'll actually start using them in your application. So it'd be auto index mode, implement to turn it on, You can do report only, and I kind of like this feature because it reminded me of the automatic or the adaptive optimizer, where you can say, oh, just, you kind of get your toe wet, I guess, to see how it's going to work. It doesn't really use them, but it will turn them on. It'll actually report what it would turn on. The indexes still remain invisible. And then, of course, the default is not to use the feature at all. You also can control automatic indexes by schema in 19C. In 21C, you can actually now control it by table, and table takes precedence. If you have schema and then a table, the table will take precedence. So, just realize it's getting more specific with the 21C release. So, but automatic index schema basically allows you to include, exclude any schema with the allow parameter. And, the schemas can be, they are case sensitive, and they can use wildcards. If this parameter is left to null, then it means that all schemas can use auto index. And I wouldn't recommend leaving it that way. I don't know. I'm not one to just all or nothing and see what it does. I'd rather control it. And so I always put a schema here. And in 21C, again, like I said, you can get more specific and actually include or exclude tables. So how you do this is basically, there is a table out there, a view that they give. Of course, with any new features, there's a bunch of views to support the feature. And so we have a DBA or a CDB auto index config table or view. And I'm selecting a parameter name and parameter value from it. And you can see these are the defaults. And these are the things you can change. So we've got, auto index mode, the default is off. We've got some retention of reporting, 31 days. Here's your auto indexes. If you have invisible indexes that are going to sit out there and not being used, it'll delete them after 373 days. You can change these parameters, and I'll recommend what I do. But as you see here, all you have to do is exact DBMS auto index configure, and then I do auto index mode, and then implement. And this is what turns it on that you can see right here. Okay, so how you configure a schema. Basically, you do DBMS auto index again, configure, and then you pass it the parameter name of auto index schema. This is kind of longhand, and then the parameter value of greater than test, as well as allow is greater than equal to true. And there's a shorthand down here at the bottom of the slide. You can do this and not have to put parameter value and allow. You can just say exact DBMS auto index configure auto index schema, test, and false. This is me saying, no, I don't want you to put auto indexes on the schema. So here is I'm allowing it, now I'm taking it away. So that's how it works. And again, you can see once I did this, now it says, this is what it's going to auto index on. There's a lot of things you can do with configure. And like I said, that you've got the retention for auto indexes. And so when it says it's going to remove an index that's not used and they remain invisible, it will do that by default in 373 days. I think that's too long. In my testing of this, and I don't know, maybe it was a timing issue, but it would have invisible indexes that actually would create segments out there. And, it's taking up space. And, it seems like having that out there for a year seemed excessive. So I actually changed this. I can't remember what I changed it to, but I actually changed it down to a smaller amount. So I don't want those auto indexes that aren't being used sitting out there. What's nice, they also give you the option to do auto index retention for manual. So your own created indexes, the indexes you create, you can say, hey, if these aren't used, go ahead and delete them. And I like this one. I actually set this one for 373 days because, if my index hasn't been used for a year, 10 to 1, I probably don't need that around. Now, you might have some yearly processing that maybe you do need that, but you probably need to identify those anyway to maybe not maintain them, if they're only being run once a year, do something else about them so they're not sitting out there taking any processing time, and maybe you can even reduce the space with that, because Oracle gives you a lot of ways to do that. And then there's auto index report retention. And the reporting that you get from auto indexing depends on this retention period. So the default is 31 days, so you can only report 31 days back. I think that's too short. Maybe I want to report a quarterly period. I think a quarterly is kind of a nice thing because you have workloads. Maybe you have a month end or maybe you have a quarter end type workload. And so you might want to see more than just 31 days. So I actually bumped that up. And then auto index default space, it defaults to null, which means that it defaults to the default database when you create the database, or a default table space when you create the database. So that's where the auto indexes will live if you don't change it. And if you don't change it, you can always change auto index space budget. So if you leave it in the default database or table space, leave it in the default table space, basically you could give it a % of how much you want auto indexing to use. So it won't eat up your default table space. This index space budget is only used if you leave the table space to default. And then finally, there's some more. There's auto index compression. This is what I think is really cool in save space. It does advanced low compression, so it's off by default. But this is a freebie to save some space. So why not turn it on? It saves space and also can help with performance a little bit. These are just some other things with the parameter value that you can specify the parameter. If you don't specify the value, then it's going to be the default setting. And then the allow for auto index schema. This is how you can exclude, include different schemas. And I'm like I said, I haven't looked at 21C, but now you can do tables the same way. So it's probably similar to this. Okay. So there's just me setting some of the things that I like. Like I said, I like the report retention to 90 days. This is me changing the table space from default to its own table space. I actually set the space budget. However, it won't use it because I put it in a different table space. It'll only work if you use the default table space. And then here's me changing the manual retention for my indexes that I created. It doesn't do anything with indexes you create unless you set this. And then I, of course, have reduced the time of the retention for the auto indexes. So once again, you just select from that view to show you all your settings, so anytime. Okay, so with that said, the new views that are associated with auto indexing, we already looked at DBA auto index config. But you have all these other ones that'll give you a lot of information. It'll give you the rationale. If you look at these, and I think I have the query on a later slide, but you can join some of these and get the rationale of why it chose that index and actually see it work in action. So it's kind of cool that way. Let me see. Okay, so other additional views here. Like I said, it runs in a task. So you want to look at DB advisor tasks. There's some new tasks. Auto index task is one of them. Some of these others I actually highlighted because it does create baselines behind the scenes. Even if you have all of that turned off in your parameters, it still will create a baseline. So you just kind of have to look at that and see. I was kind of surprised at how many baselines it did create. And then DBA indexes, they added a new column as auto, and you can see the indexes that it created, always with sys under AI prefix, because that's how how you can identify them. Okay, sorry for my dog barking. Today, I think my house next door is being worked on. He's hearing all this noise, so he barks a little bit. So SMB $config is another table you can look at. It will show both the hidden parameters as well as this regular parameters set for auto indexes. You can see much more in this table besides just auto indexing, but I've actually looked for % auto index % in the query. So I get all the hidden parameters with the underscore here, as well as, the regular parameters. So just another way to look at what you've got set for auto indexing. Here is how you can drop secondary indexes. You actually can use auto index to basically drop any secondary indexes, except the ones that are used for constraints. And you can do that for a table or a schema in 19C. And so the command is just begin DBMS auto index drop secondary indexes, and I'm dropping a schema. Again, you can actually put a table name, a schema, a table name here as well. And then finally, you have reporting, and this is the different reports, and it's typical Oracle and how you run any reports. They usually give you a function that you can run, and you can pass things. And I gave you two different options of how to run it. One, a little PL SQL block, or you can just run the function with a select from dual just by passing it the different things. And the report activity one basically allows you to give it a time range. You can the last activity basically just will report the latest operation. So that one's really quite nice, especially if you just said, give me what you just did type thing. Here's all the options for reporting. You can get XML, HTML text. Here's your different sections that you can do. You can exclude, include the different sections. Just like I said, typical reporting from Oracle. And then here are the two hints that they've added: the use auto indexes or the no use auto indexes. And that's, I believe, is how they're controlling, especially if they've added an index where some SQLs regress, they may use that no use. Okay, here's just an example of report activity. And so here you can see I'm just running this function here, passing in, give me last day. And as you can see, what I've got here is it found 21 candidates, but it only created 3. And no invisible, it just saw 3 visible. And it actually took up almost 95 megabytes of space. They were all visible. It didn't drop any, and it verified 12 SQL statements. And out of those 6 SQL statements that it actually verified, it improved the 6. And then it gives you the improvement factor. I don't know how they come up with that number, but 722.5 times improvement for those 6 SQL statements. It actually created 2 baselines. And then it says the overall improvement factor is 7,405 times the amount. So again, I'm not sure how they come up with that number, but it sounds impressive. Nothing done with the manual indexes, and it'll always show you that as well. And then it goes into, okay, what did it do? And so it says, okay, I created these indexes. And like, as I showed you, I had a schema out there called test. And I was doing a lot of my testing. So really, the only one that I was really interested in was this AutoIX test table. And it was just a simple table that I created from HammerDB. And I just took, kind of stole some information. But it created this index on this, this column. And the query that I was running was delete from AutoIX where district number equal 10, and then I put a row num, I put a limit on it of 4950. And so then it tells me improvement factor of 48,902. So again, looks pretty impressive. But if you look at really what the original plan did versus what the auto index plan did, it does look impressive. Look at the buffer gets, 48,902 buffer gets versus 3. A CPU time, just really small versus what it was doing originally. Great view on all of that. You can see too that it actually looked at another query, select star from AutoIX, again, where district number equals 10. And again, it improved it, and shows you the improvement. And then finally, it shows you the execution plans. Of course, it was doing a full because I just created the table and that's all I did. I didn't put any indexes on it. And then, of course, it found an index that it thought it should use. And then of course, that improved performance. I look at the cost, 12,092, got it down to 8. So looks like we improved it. Okay, so here's just report last activity. Like I said, this one I do a lot. It's just easy to type this in because you don't have to really put anything in. It'll take all the defaults. You can specify, and I kind of just put this in to show you that if you want to get the different sessions, this is how you do it. Maybe I want summary and index detail only, then I just do plus. Maybe I want it all, but I don't want to see the errors. Then I can just do minus, and so that shows you the exception and the additions of them. Okay, so I kind of hurried through that, but I really wanted to get to my case studies, and I have a few case studies that I've done tried and true from I say version 10 and up. I don't know. I may have done it in 9 as well, but these are 3 case studies I've used over and over again, not only in Oracle, but many other different data type-based types, and they always ring true with indexes. So, I thought, previously slides and things that I've done, I always compared it with Tuning Advisor. And when I did that, it always seems kind of consistent that the advisor usually missed the mark. It got close, but I still felt you still needed a DBA. And so anyway, I wanted to see what automatic indexing would do. So these are the 3 case studies I'm going to quickly run through. And if you've ever seen me talk about tuning, you probably had heard this tried and true case study many times. But this happened to actually come into a customer years ago that was having problems. It was a university, and they were having problems getting their billing out. And it was running slow. And so we got on, we looked, and we found this query. And it was basically trying to find which students registered for which classes to bill them with. And so it was selecting first name, last name, sign up date, from student. It joined it on the, kind of the detail table, registration on student ID. And then it joined, a class to registration on class ID. And for the real case study, for the real problem, they were actually passing in different classes, but I've just kind of made it here for this example. SQL tuning. So they're looking for class name of SQL tuning, and they had a range here. I just made it for yesterday. So the sign up date and registration was between yesterday, if you will. And registration happened to be a historical table. So it was, a rather large table. If students canceled or, dropped a class, basically they just marked, they never deleted from it. They just marked the cancel flag equal to Y. So we're getting only active records here. And you can see my table size is wasn't that big, 80,000 rows, 18,000 rows for student, and 1,000 rows for class. And here were the indexes that, actually existed on it. It was basically holding up, just referential integrity. It had a whole bunch of primary keys and foreign keys that, well, actually all primary keys. It had no foreign keys on these. So I threw auto indexing at it. And of course it was in test, so I didn't really have to do anything but start and load. And what you can see here is it automatically created a bunch of indexes. Now, I had other things running too. So it actually created 2 indexes on class. And it looks like 3 indexes on registration, no indexes on student. And, running my little load of that query. And as you can see here, you can see the breakdown of the indexes. The first index was on class ID and name, and then it created another index just on name. And then on registration, it created an index on class ID and canceled. It created an index on canceled, and then it created an index on student ID and class ID. The reason why I have these underlines, this one with the suffix of FFNN on name, for class, and the one with JXOV on registration, is those are the 2 that they decided to use. They created these others invisible, but they didn't use them. So here is this query that I was telling you I can use those other views to actually get the rationale of what it did. And so I can see by selecting execution name, table name, index name, stat name, and start time from auto index IND actions and auto index statistics, and I join that with execution name, I actually get the rationale of what they did on this index in registration, and which was class ID and canceled. And so you can see the ones I got, it first created some baselines. And it's seen that the statements were improved, so it created baselines. And then it decided to create the index invisible. And then it said, oh, no, I'm going to create it visible. And, that's the rationale. Down here at the bottom, you can see that this one statement, it said it improved. And actually, how it's seen that is just looking at buffer gets. 17,087 buffer gets it did in the original query with the indexes. It only did 325. And you'll actually see that in the plan when we start looking. So, so you can actually look what's taking up space by just looking at user indexes where auto equals yes. And you can see that I have, the status, they marked all those other indexes unusable. But, the one that FFNN, that was the name in class, that actually marked it visible, and it has a segment now created. So it's taking up space, as well as the one with JXOV that was on class ID and canceled. And that is now valid and is taking up space. They're still invisible, notice, but you can see the space that it's taking up. It's taking up a little over, I guess, about 2 meg of that for that. Now, one thing I forgot to do is I didn't turn auto index compression on, and I should have. I mean, it's a free thing, and you're saving space, so why not? And so, I actually turned it on, and you can see now that they're all advanced low compression. And you can see that some are visible now. It actually made it visible eventually as it was processing through. And, some were left invisible. I was testing, but it still took up space. So now I can do a report on it. And so this is going to tell me what it did. It created 14 candidates. It actually created 6 indexes, 2 visible, 4 invisible. It actually took up, about 7 meg, 2 megabyte for visible, 4 megabyte for invisible. It didn't drop any. It didn't create any baselines, but it improved for one statement, 52.6 times factor. And then overall improvement, it was 17.5. As you can see here, and this little thing is in my way. I don't know how I can minimize it. Sorry, it's the you guys probably can't see it, but it's the controls to zoom. But I had to move it to actually get down to the bottom of my slides. But as you can see here, it actually used this. It actually looked at FFNN. It actually used this index on name, class name. And there's my rationale of this 170,870 and 342. We saw that back in earlier slides of why it's using that index. So it improved it. The thing is, when you're looking at it, it's still doing a full table scan on registration. Registration was my largest table at 80,000. Class was only 1,000 records. And I don't like that. I mean, it did improve it. It got it down, the cost is 105%. But why didn't you use the index on registration? It kind of upset me when I first seen it. Did it measure up? In my opinion, no, because I got the cost down to 107, but it's not the best index for this query. And so for me, when I tuned it in my case study, I put a covering index on registration, and I also included the class name index, and I got it down to 5. So as you can see here, it's using both indexes, and we're not doing the full table scan on registration. This is just, a tool that I use, and you can see this is that one that eventually I let it run long enough, it decided to change. And, this is where it's always continually analyzing. So I was disappointed at first, but it did the right thing. It said, I found, this is really a much better index. I'm going to add this index with ending in a JXOV, which was on class ID and canceled. It's going to actually add that, and it's actually going to improve performance. So as you can see here, this was the buffer gets that it was doing with the auto index. We can see number of executions, number of rows processed, you know, and we can actually see the cost of that now. So it did reduce the cost from 107 to 76. So again, it did pretty good, but again, it did not do as good as me adding the covering index. And because adding a covering index, it didn't have to go back to registration. It didn't have to look at the whole table. It could just resolve itself with the columns in the index. So all I did was add sign update, and it didn't have to go back and visit the table. So I'm saving some IO there. But I also added the index on class name. And so, with me doing it with the covered index, auto index got 4 million buffer gets. I got it down to 658,000. We reduced CPU usage. We reduced elapsed time. Actually, I try to do 10-minute cycles. Some of these, they run them in loops, and they ran out because they were running more efficiently. So didn't get as much rows processed, but still you can see it did improve it. So overall, this one, it did come up and reduce itself in time, which is good. I don't know how long I would have had to run it, or if it would actually have added the two indexes together. It may have. Of course, this was a case study that I ran and played with for a week. Maybe if it ran out there longer, it would maybe have resolved that. But again, the DBA, in my opinion, wins on this one, which I'm always looking for a reason, to tune. So it kind of made me go, aha. But still, it did a good job. Now, the second case study here is on Hammer DBE. I use that. It's a little order entry utility. And I found kind of a complex query that I modified a little bit to kind of make the optimizer work with a lot of bind variables, a lot of greater thans and less thans. And you can see the sizes of my tables here. You can actually see order line is 60 million, orders is 6 million, districts only 50. But customers pretty hefty, 150,000, in stock at 500,000. Hammer DBA always comes and indexes their own stuff, so I left the indexes just the same as it came. And then you can see the cost of this query was quite costly, 15,981. It did a skip scan on district. That was only 50 rows. So normally I don't like skip scans, but since it was a small table, probably not a big deal. But look at my full table scans. Orders was 6 million. Customers was 150,000. So, those are large tables, why not using the indexes? So you can see it was, running on average of 0.29 seconds, 10 million buffer gets. It processed a lot of rows. But we let auto indexing, take control, and here it created some indexes. Some on customer, some on orders, one on stock. Nothing on order line, which was my 61 million row. Which I thought, well, maybe it had a right index. So we look here and we can see the breakdown. Of course, these are the ones it used. It used a customer C last. And it used this other one with that suffix in YXN with customer ID, district ID, and warehouse ID. It put one on orders, but what you'll see is it didn't use it. And again, it might be over time, it may have used it, and had I ran it for weeks and weeks, but really it just put the two indexes here on customer. And, so it didn't use the other one on the orders. It's actually doing a full table scan on orders, as you can see here. Okay. So again, here is, what it did. It did improve it. And it improved it quite a bit, actually. It actually improved the response time, although the response time wasn't that bad to begin with, 0.26 seconds as opposed to 0.29 seconds. Look at my buffer gets, though, 10 million now down to, 1.8 million. So still, pretty good there, that it did improve it. So, there's promise. I tuned it. I actually added one on orders. And I added it on order ID, customer ID, and entry date. And of course, I reduced the cost greatly. So yeah, again, maybe I'm being picky. I did get results. It did tune it. But I think, there could have been a little more work. Finally, my last query, and I think I'm running out of time. I hate to be running, but we got a few minutes here, is on airline flights. And this is kind of a fun thing. If you've never done it, if you go to the US Department of Transportation website, the link is here. If you'll get my slides, you can click on that. It'll take you there, and you can download any flight in the United States. I don't know for how many years. I downloaded for the year 2015. And you can see what I got in that year. I got, this is the fact table, T on time, and I got almost 7 million records. So, you could probably get a huge data set. But if you want to play with a star schema, this is kind of an interesting to play with. And before COVID, I flew a lot. And so I wanted to, actually create this little select statement that actually told me, okay, what flights are popular, to what cities. So I always, at that time, was always flying out of Denver. So my city was always Denver. But if I entered the day of the week, and then I wanted to know the most popular flights, that were flying out and which, days, just as if I had a choice. Usually I didn't have a choice because I had to do it for my work. But, it's just kind of an interesting query. And so you can see that there wasn't that many tables. There's, lookup tables of carriers, airports, the city, and then the number of weekdays, and then my fact table again on time. When I downloaded, you download through Excel spreadsheets. So I had no other option when I loaded it because I had no indexes. So it was very costly. CPU cost was 31,000 and some, all full table scans because there were no indexes. It chose to do a hash join, probably because of that very large table. Although there were lookup tables, but probably less expensive to do a hash join. So I let automatic indexing kick in, and as you can see here, it created a bunch of indexes on all the tables. Actually, it created quite a few on my fact table, but the only two it ended up using was city market ID, the description, and T on time. The originating city market ID. And, it did create quite a few visible indexes though. As you can see here, again, oops, let me go back. As you can see here, it did one on airport ID as well as the carriers, and another one on market ID on code. So it didn't use them all, but it did create them. So again, they may sit out there and may decide to use them after running them for a long time. As you can see here, oops, let me go back there, sorry. You can see what it did. So it looked at all the indexes. It said we can improve the factor, and then it gave me the actual execution plan here of the actual statistics. And you can see the CPU time was over the roof. It did improve it. It's still pretty high. The optimizer cost was the same though, but it did do less buffer gets, so pretty neat there. And here's just the execution plan and showing the two indexes it used, as you can see here. So one on market ID and then the one on time. And there's the cost, which was the original cost was the same, but it did improve it because of the buffer gets. So original performance, almost 11 seconds response time, 19 million buffer gets. After it improved it, 0.46 seconds. So it did improve it. In fact, I couldn't keep it running because it improved it so much. And look at the 19,000 or 19 million, sorry, buffer gets down to 4 million, almost 5, but still a great improvement. So in summary, they've come a long way. I have to give them, I really like 19C's automatic indexing. because it does speed up performance. And like I said, in my case studies, it wasn't running a long time. And if you think about turning automatic indexing on, especially in an Exadata environment where it's continuously looking and evolving, it may be spot on eventually. So, like I said, they've done some work in 21C. Basically, they've included now that you can include and exclude specific tables. They've actually fixed a cursor problem that was kind of hurting performance in the background. And then they've actually made it so it uses more choices. And I'm hoping, because what I didn't see is that they combined a lot of cross table indexes. And I'm hoping, and this is what, stay tuned, because I hope to do this same, my same case studies in 21C to see if it might actually use, cross table indexes in the same query. So a couple things, just beware of turning it on blindly, especially if you're not on Exadata. I always use, the schema, I don't turn it on just for the whole database. Watch out, for baselines, because it does create baselines in the background, and you may, make sure you have space and all that. And also watch out for invisible, indexes that are actually consuming space and maybe taking up too much space. So, and I would really consider, especially if you don't have Exadata, turn it on in development test. Why not? And just see what it would do, and what indexes it does suggest, because it could be a great help and a shortcut when you're trying to get things in production. And then also just one last hit is turn on compression. Come on, it always helps to save space. So with that, I'm done with my presentation. I want to thank you for joining me here today. I think I answered all the questions, but let me scroll down, make sure. Here is one that says, will it create indexes that prevent storage cell pushdown? And that's a great question. And unfortunately, I don't have Exadata to play with and know. It might be in the manual somewhere. I'm sorry, I can't answer that. And then another question is, will it create B-tree indexes on OLTP systems? Yes. And then how does it know it's on? Well, it doesn't really, he asked, how does it know that's on like a data warehouse or whether it's in a transactional database? And it really doesn't. It just looks at the workload. So, and it's actually looking at, how it's performing. And typically it's probably looking, at the way a lot of, uses of indexes is buffer-gets. It's using buffer-gets to, see if it can't improve that. Because if it's reading far too much data, that's one way to speed it up. The marketing slide that I kind of showed from Oracle, they're saying that it actually is a must-have in highly transactional environments. Because think about it, if you're taking an order, you don't want that guy. In fact, we had a customer that is a billing system for ordering, and they actually found out and figured out that if a customer had to wait more than 5 seconds on a website, they would actually close it and go on and not use their billing. And so they were very adamant that it had to be very, very fast. So transaction processing, is you've got people waiting for an answer, where a lot of times data warehouse, it's analytical and they can take longer. So it's useful there too, but that was just what Oracle's suggesting for transactional environments. Ravi says, does this feature also look at index fragmentation and reorgs? No, it doesn't. I don't believe. It does look at statistics, though. If you have no statistics on the underlying table, it will not, it will not look for any indexing. So make sure your statistics at least are there, but most importantly, make sure they're up to date too, because that's going to give it even more information in order to create the best index. And then finally, Matthias has said, how can you guarantee production and test databases behave the same? And that's a good question. That's one I always try to answer. Always wished I had the exact mirror in test and I do production. And that depends on your company. I hate the standard answer, depends, but basically, if you do have the environment where your load, you're running a production like load, hopefully you have the same hardware, the same, all the same power, everything looking pretty much the same in order to do that. Of course, if you don't have that, then yeah, you can't really depend on what you're doing in tests is going to be a surefire thing that happens in production. But there are tools out here today that you can use to run a production load. You can record a production load, and if you have the same equipment in your test environment, you can pretty much get pretty close. And then finally, Matthew's asking, and this is a good question, is won't all these invisible indexes slow down DML? And I don't believe it will. It's metadata. Unless they actually do create a segment, I wouldn't expect them to slow down anything because it's metadata. So, I mean, I guess, again, it's another depends, depending on how many invisible indexes it's creating. It's something to watch, I would. But again, another reason not to turn it on for the whole system. Just use it on your applications that you want to use it on. With that said, I think that's all the questions. Again, I appreciate you all joining me today. You guys have a great day. Thanks.
Thank you so much, Janis, and thank you everybody for sticking with us over the hour. I have never seen such great, oh my gosh, Janis, you have tons of thank yous, excellent presentation, impressive explanation, so much great feedback. So we thank you so much, Janis, for your time and your expertise.
Thank you, Monica.
You're always a phenomenal presenter, and on behalf of NYOUG and Viscosity, we thank you. We thank everyone for showing up today. Yes. I know you guys are eager to get resources from today's session. Just hold tight. It will take a while to render. Katie will get you what she can when she can, and you can always go check out nyoug.org for sessions like this. We've also got them housed in OraPub, so you'll have that information soon. And thank you again, everyone. I hope you guys have a great day. Take care, and we'll see you at the next webinar.
Bye now.